Hello students, welcome to chemistry classes. So in this video we are going to discuss the chemical properties of alkenes. So far we discussed the preparation and the properties of alkenes. Now the chemical properties of alkenes. First of all, addition reaction, addition of dihydrogen, addition of dihydrogen or hydrogenation or reduction. So the normal way of addition, ethylene reacts with hydrogen in the presence of platinum or palladium or copper or nickel or nickel. So any one of the catalyst is used for this process. So we are getting alkanes as the product, alkane as the product. Similarly, propylene reacts with hydrogen under any one of the catalyst, it provides propane as the product, propane as the product. Second method, addition of halogens. So addition of halogens, ethylene reacts with chlorine in the presence of carbon tetrachloride, gives CH2Cl, CH2Cl. 1,2-dichloropropane, ethane, 1,2-dichloroethane as the product. Similarly, propylene reacts with bromine, it gives CH3, CHBr, CH2Br, 1,2-dibromopropane, 1,2-dibromopropane is the product, 1,2-dibromopropane is the product. Now, addition of hydrogen halides, addition of hydrogen halides. So, in this addition reaction, we are classify the alkenes into two categories, symmetrical alkenes and unsymmetrical alkenes. So, what is symmetrical alkenes? So, in between the carbon-carbon double bond or in between the double bond, same number of carbon atom present means it is a symmetrical alkenes. Symmetrical alkene means simple addition reaction may takes place, addition of hydrogen halides and easily takes place. For example, ethylene. Ethylene is a symmetrical olefin. Why ethylene is a symmetrical olefin? In between the double bond, here one carbon atom, here one carbon atom. So same number of carbon atoms are present. Therefore, it is a symmetrical olefin. It reacts with the hydrogen halide HBr. HBr split into H plus and Br minus. Suppose the Br minus attached here means this bond shift here. This methylene group carries negative charge. This negative charge attract the proton. So it gives CH3, CH2Br. So normal addition reaction. Suppose taking 2-butene. 2-butene also symmetrical olefin because here 2 carbon atoms, here also 2 carbon atoms. Hydrogen chloride, CH3, CHCl, CH2, CH3. 2-chlorobutane as the product. 2-chlorobutane as the product. So addition of hydrogen halides towards simple olefins or symmetrical olefins. Suppose we are taking unsymmetrical olefin, the expected products may differ. It can be explained by the famous rule called Markovnikov rule. So what is Markovnikov rule? In the attacking reagent, this is a HBr is a attacking reagent. Attacking reagent ionizers produce H plus and Br minus. Negative part of the addendum, attack carbon-carbon double bond containing lesser number of hydrogen atom. That is the Markovnikov rule. What is Markovnikov rule? In the unsymmetrical olefin, the addition reaction may take place, that is addition of hydrogen halides may take place, must follow the Markovnikov rule. In the attacking reagent, negative part of the addendum attack carbon-carbon double bond containing lesser number of hydrogen atom. For example, we are taking propylene as the example. Propylene reacts with the HBr. Propylene reacts with the HBr. Here the carbon-carbon double bond. Here 2 hydrogen atoms are present. Here only 1 hydrogen atoms are present. So H plus Br minus. So attacking reagent. Negative part of the addendum attack. Carbon-carbon double bond containing lesser number of hydrogen atom. So the product is CH3, CHBr, CH3. 2-bromo propane as the product. 2-bromo propane as the product. So similar way the reaction can be takes place for the higher order alkenes also. Higher order alkene also the similar way of reaction may takes place. So this is Markovnikov rule, addition of hydrogen halides. What is against of the Markovnikov rule? Anti-Markovnikov rule or anti-peroxide effect or Keras reaction. The reaction is called anti-Markovnikov addition or peroxide effect or Keras effect. Just opposite to the Markovnikov addition. We are using benzoyl peroxide. So CH3, CH double bond CH2, HBr in the presence of peroxide. Simply say peroxide, any one of the peroxide, hydrogen peroxide or benzoyl peroxide. Normally benzoyl peroxide is used for this peroxide effect because the reaction follows the pre-radical mechanism. Benzoyl peroxide is easily formed. Therefore, the reaction is carried out with the help of peroxide. So in the peroxide, just opposite to the Markovnikov addition, H plus Br minus. Negative part attack here. So the product is CH3, CH2, CH2Br. 1-bromo propane is obtained. 1-bromo propane is obtained. So this is very important in the case of in the examination point of view. What is Keras effect? Keras effect means peroxide effect or anti-Markovnikov rule. How the addition reaction takes place in the olefins by using Markovnikov rule. So now you may go through the problem 13.12 in your textbook. 13.12 Keras Effect. Write the IUPAC name of products obtained by the addition reaction of HBr2 Keras Effect, absence of peroxide and presence of peroxide. First you should write the molecular formula or the structural formula for Keras Effect. Keras Effect. Hexene consists of 6 carbon atoms. In first carbon, in between carbon number 1 and 2, double bond may be present. Therefore, it is said to be Keras Effect. Problem 13.12. Keras Effect. So 6 carbon atom. Numbering the carbon atom 1 gene. So double bond CH2, CH, CH2, 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 CH3. Addition of hydrogen bromide. Addition of hydrogen bromide. Presence of peroxide. Here absence of peroxide. Presence of peroxide, that is a peroxide effect. Peroxide effect, hydrogen Br is added, bromine added here, hydrogen added here. So the product is CH2Br, CH2, 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 CH3. 1, 2, 3, 4, 5, 6. 1 bromo hexane as the product. Absence of peroxide means it follows the Markovnikov rule, bromine added here. So CH3, CHBr, CH2, CH2, CH3. 2 bromo hexane is the product. 2-bromohexane is the product. Now, the fourth reaction is addition of sulfuric acid. The addition of sulfuric acid, the cold concentrated sulfuric acid is added to alkenes. This reaction also takes place in accordance with the Markovnikov rule. That is, the electrophilic electrophilic addition reaction may occur. Sulfuric acid, it is written like this: sulfuric acid, addition of sulfuric acid, H plus and HSO4 minus, H plus and HSO4 minus. So, simply say CH2 double bond CH2 plus H2SO4 means here the hydrogen may add here CH3 CH2 HSO4, ethyl hydrogen sulfate, ethyl hydrogen sulfate as the product, ethyl hydrogen sulfate. Suppose we are taking propane, means propene CH3 CH double bond CH2 plus H2SO4. So, what is the product form? CH3 CHHSO4 CH3. So, the negative part added here, hydrogen added here. So, this is propyl hydrogen sulfate, propyl hydrogen sulfate as the product. So, the addition of water, the next reaction is addition of water. Addition of water, this reaction also takes place in accordance with the Markovnikov rule. Water merely not added to the substrate in the presence of little acid, either concentrated hydrochloric acid or concentrated sulfuric acid only catalyze the reaction. Here also H plus HSO4 minus. So, here H plus is added means here H plus and OH minus, here OH minus is added. So, CH3 CH2 OH, ethyl alcohol as the product, ethyl alcohol as the product, addition of water. So, you may practice with propene. Propene reacts with water. Propene reacts with water in the presence of little acid. It gives isopropyl alcohol as the product. This reaction can be takes place in accordance with the Markovnikov rule. Suppose the anti-Markovnikov rule means N-propyl alcohol may occur. Then some more reactions also possible. The next reactions are discussed in the next class. If you have any doubts, you may ask. The organic reactions are very important in the examination point of view. So, you should practice very well. Practice with higher alkanes. I explained on the basis of ethene and propene. You may practice with 1-butene, 2-butene and pentene, hexene, etc. So, in the reactions may be in the normal condensed system or it may be in the bond line representation. Thank you.